Hey, welcome back to your favorite trig class. Let's continue on with applications for this right triangle trig unit here. A surveyor can measure the width of a river. So let's say we've got this. Come on. Uh, we've got this river. River. Taking a siding of a point A. Oh, I'm sorry. By setting up a transit at a point C. So we've got this point C right here. Okay, right here. On one side of the river, taking sighting point A on the other. Okay, the other side, point A. After turning through an angle of 90 degrees at C, the surveyor walks a distance of 200 meters. Okay, so we've got this 200 meters to point B here. Using the transit at B, the angle theta is measured to be 20 degrees. So right there we got a 20-degree angle right there. Okay. What's the width of the river? So we want to know B right here, right? What's the width of this river approximately, right? What's the width of the river? B. Rounded to the nearest meter. And I say, well, I've got this 20-degree angle and I want to know the opposite side of 20 degree, and I have the adjacent side, right? I want to know the opposite, but I have the adjacent side with respect to angle B or angle theta, this 20 degrees. Okay, so I say, well, opposite over adjacent is the tangent. Opposite side over the adjacent side, 200 meters. Now we just multiply both sides by 200. So we got B equaling 200 times the tangent of 20 degrees. Now you have to be in degrees. When you punch this in, you'll get 72.794. Again, make sure you're in. I guess we got to round that to the nearest. 0.79. Well, I guess the nearest meter would be 73 meters, right? All right, let's do another one here. We got this straight trail leads from the Alpine Hotel to a scenic overlook. Right, so we're on this trail. Goes to this scenic overlook. Whoops. Goes to this scenic overlook at 11,800 feet. So the difference there is 3,100 feet, right? So we know that's 3,100 feet from the original elevation of 8,000 that we started at. We end up at 11,100. So we know that height's 3,100. Length of the trail. So we got 14,100 feet is the length of the trail. So what's the measure of angle B right there? What's the measure of angle B? Well, with respect to angle B, I know the opposite side and I know the hypotenuse. Well, who's opposite over hypotenuse? So I say the sine of B is opposite over hypotenuse. 3,100 over 14,100. And then we got to undo B, right? Undo the sine. So we got to use the arc sine. The arc sine. And here, if I'm in degrees, my calculator's in degrees, I punch this in, it'll end up being 12.7 degrees. So that's that inclination, right? This is 12.7 degree inclination. All right, little vocabulary. An angle of elevation, that's your angle of elevation. Angle of depression is that angle from down, right? From your line of sight down. That's your angle of depression. Okay. All right, finding the height of a cloud. So meteorologists find the height of a cloud using an instrument called a ceilometer, which consists of a light projector that directs a vertical. So you got this light projector is projecting light straight up to the cloud, to the base of a cloud, and then a light detector over here. We've got the light detector that could scan the cloud to detect the light beam, right? So it's scanning the cloud to pick up where that light beam hits on the cloud. So this airport it was used to find the height of the cloud. So it was set up where the difference between the light detector and the light projector was 300 feet. Okay, and we want to know the height h right here, right? The height h, and this angle here is 75 degrees, the angle of elevation, right? They call that. So the angle of elevation is 75 degrees from the ground up to that, where it's spotting the light there from the light projector. So I say, well, this is the opposite side. I know the adjacent side. Opposite over adjacent is tangent. So we're going to go tangent 75 degrees is the opposite side we called the height. Over the adjacent side we call 300. I'm going to multiply both sides by 300. Make sure my calculator is in degrees. And this is 119.615. So approximately 1120 feet. We're going to go to the nearest foot there. All right. Bearings. Bearings. If you ever hear, let me go through these, north 30 degrees east. So you want to think, okay, first I'm going, it's off of north or south. And in this case, it's off of the north. And it's rotating 30 degrees to the east. So that's where your angle is. That's north 30 degrees east. If you do south 50 degrees west, now you're off of the south and you're going in the west direction is that rotation. So your 50 degrees would be right in there, south 50 degrees west. If you've got north 70 degrees west, off of the north, I'm going to go and rotate to the west 70 degrees west, right? That's your angle for north 70 degrees west. So it says, what is the bearing from O to an object of P4? So what's the bearing here, right? What's this? So you got to see how that's 20 degrees. So you say, well, south 20 degrees to the east. South 20 degrees to the east, okay? All right, so we got this Boeing 777 aircraft takes off from Nashville International Airport, which has a bearing of north 20 degrees. Get back to my beloved blue here. North 20 degrees east. Okay, so we've got this. Let's see if I can draw this. Here's your starting here. North 20 degrees east, and it goes for 1 mile. So here's our 20 degrees in there. Okay. After flying for a mile, the pilot of the aircraft requests permission to turn 90 degrees, so it turns towards the northwest. So it turns, making a 90-degree angle right here towards the northwest. The request is granted after the plane goes for 2 miles in this direction. So now it's gone 2 miles, so double the length there. What bearing should the control tower use to locate the aircraft? All right, so here's where the aircraft's at, right here. So what we're wondering is, what's the bearing? In other words, what is the angle theta back to it? You know, north, so it would be north theta degrees west, right? We're north theta in degrees west. That's our question, right? So what can we do here? Well, we have let me call this angle A right here, and that's that whole angle. That's the theta and the 20 degrees, angle A. With respect to angle A, I have the opposite side and I have its adjacent side. So number one, what I'm going to do is I'm going to say, well, the tangent of A is opposite over adjacent. And then I'm going to take the arctangent on both sides. So angle A is the arctangent of that 2 over 1. And I punch that in, and I get 63.4 degrees. Okay. Now that's the entire, that, hold on here, let me black. Angle A is the whole thing, but we only want theta, right? So number two, the theta then would be, the theta plus 20, angle A is theta plus the 20 degrees. And we know angle A is 63.4 degrees. So theta, subtract 20 on both sides, got to be 43.4 degrees. So what's the bearing? Well, then we say, oh, it's off the north, 43.4 degrees, 4 degrees west. North, 43.4 degrees west. Well, thanks so much for listening. We will see, there's a little better picture of that. We will see you guys next time.